So good day again everyone, this is Jeco Tesorero from BSCE 4A, and today I'm gonna report to you the soil classification according to Aashto and Uscs classification system. So first, what is the Aashto classification system? The Aashto classification system was developed in 1929 as the Public Road Administration System, one of two classification systems that is commonly used by geotechnical engineers nowadays. This system takes into consideration the particle size distribution and the Atterberg's limits of the soil. The American Association of State Highway Transportation Official, or AASHTO, is a standard setting body which publishes specification, test protocols, and guidelines that are used in highway design and construction throughout the United States. Although AASHTO sets transportation standard and policy for the United States as a whole, AASHTO is not an agency of the federal government, rather it is an organization of the states themselves. Next, group classification using Aashto system. Now here are the groups. So there are 7 groups. So in A1, group number 1, there are 2, the A and B. Number 2 naman, there are 4 classification, A-3, and so on. So in group 1, 2, and 3, they are granular materials with 35 or less of total sample passing the number 200 sieve. It is general good subgrade rating excellent to good. While the group 4, 5, 6, and 7, they are silt clay materials with more than 35% of total sample passing number 200 sieve. It is general subgrade rating is from fair to poor. Next, this is the test required to classify soil using Aashto classification system. There are 2, the sieve analysis and the Atterberg limit test. Under the sieve analysis, there are 3. Number 1, percent passing number 10 sieve. Number 2, percent passing number 40 sieve. And number 3, percent passing number 200 sieve. For our Atterberg limit test, we will have 3. First is the liquid limit, 2 the plasticity limit, and 3 is the plasticity index. So next, how to calculate the percent passing number 10, 40, and 20 sieve. So here are the table of sieve number 4, 8, 10, 20, 40, number 100, number 200. So we are looking for number 10, number 40, and number 200 sieve. So in this table, it is given already the sieve, the retained mass, and the percent of retained. So we are now calculating the percent passing. So I already give the answer. So in determining the sieve number 10, so it is just 40 per the percent retained minus the percent of passing of the number 8. So then we will get the percent passing of number 10. So the formula we will use is percent retained minus percent passing of the sieve. So that's simple. Next. So in using Aashto classification system, we will use the method of elimination in determining the classification of soil. So I'm not gonna discuss to you. It's more complicated. So next, I'm gonna discuss to you while in our solving. Method of elimination in Aashto classification system. This is 8 to 4 to 7. So next is the group index. Group index is an indicator of the quality of the soil. The lower the GI value, the better quality of the soil. So we have our formula. GI is equals to F sub 200 minus 35 quantity of 0.2 plus 0.05 quantity of liquid limit minus 40 quantity 0 plus 0.01 quantity of F sub 200 minus 15 close quantity times the plasticity index minus 10. So where F sub 200 plus percent passing number 200 sieve. So here are the steps in determining the soil classification using Aashto method. Number 1, we will conduct a sieve analysis and determine the following. Letter A, percent passing of number 200 sieve, percent passing of number 10 sieve, and percent passing of number 40 sieve. Number 2, conduct Atterberg's limit test and determine the following. So, I hope that other reporter discusses about the liquid limit of soil, plastic limit of soil sample, and plasticity index of soil sample. And step number 3, conduct the method of elimination. So, using conduct of elimination, we will see on the table that I posted before. So, we will use the table in conduct of method of elimination. So, number 4 is compute the group index of the soil sample. So, I already discussed to you what are the formula we will use in identifying the group index of the soil. So, let's go to our problem solving. So, using a 500 grams of soil sample, determine the following using Aashto soil classification system. Here are the table given below. So, we'll read the given is already sieve and also given the liquid limit and the plastic limit. So, now what we're looking for is we have 5. Letter A, percent passing number 200 sieve and percent passing number 10 sieve. For letter C, percent passing number 40 sieve, and letter D, classification of soil. So, in classification of soil, we will use the method of elimination. Also, in group index, I already posted the formula, so it is easy for us to solve and to look what we are looking for in this problem. So, in the sieve number, you have sieve number 4, number 8, number 10, number 20, number 40, number 60, number 100, and number 200. So next, while solving, I already discussed to you how to solve for percent of retain and percent of passing. So I already sent the solution, the much broader solution. Next. So sample solution, after looking at the table, we will give the percent passing of number 200 sieve is 40%, percent passing of number 10 sieve is 88%, and percent passing sieve of number 40 is 78 sieve. So next, classification of soil. So today, I'm gonna show to you how to find the classification of soil. So given the liquid limit of 35% and PI is 12%. So, classification of soil using the table, our table is A6 or clayey soil. So for our group index, we are already look the value, so we will substitute all the value to the formula. So that's all for Aashto classification system. Next is the Unified Soil Classification System, USCS classification method. So introduction, the Unified Soil Classification System, USCS, is a soil classification system used in engineering and geology to describe the texture and grain size of soil. The classification system can be applied to most unconsolidated materials and is represented by two-letter symbol. Each letter is described below. So the first letter, G, means gravel, S means sand, C, M means silt, and C means clay, and O means organic. So sa second letter, P, poorly graded, W, well graded, H, high plasticity, and L, low plasticity. So this is the table we will use in identifying the kind of soil, whether it is GW, GP, GM, or GC, and so on and so forth. So it is the Casa Grande plasticity chart. So we will use also this in making a chart or table on our given. So I will discuss in our problem solution. So you will be learned. Next, group classification symbol if USCS is used. So here are the group symbol or group classification. So we have 28 group symbol if USCS is used. Next. So needed data to classify soil using USCS method. So percent fines, percent sand, percent gravel, and uniformity coefficient and coefficient of gradation. So by this 5 we will use the sieve analysis, and for liquid limit and plasticity index we will use the Alterberg limit test. So sample problem, classify soil using USCS method if the result of sieve analysis and Alterberg limit test as follow. So here are the given. So also the given the liquid limit and the plastic limit. So liquid limit is equals to 60%, plastic limit is 40%. So we have sieve 1/2, sieve number 4, sieve number 10, sieve number 20, number 40, number 60, number 40, and number 200. So here's the answer. So percent fines is 9% because it is number 200 passes all the sieve. Percent sand is 88%. Percent gravel is 3%. Uniformity coefficient and coefficient of gradation is already posted the formula on my problem solution that I given to our classmate. So liquid limit is equal to 60% and plasticity index is 20%. So while looking for our solution, we will look what kind of soil is our problem. So by looking the table, the answer is SP, SC, or poorly graded sand with clay cells. So that's all. My report all about USCS classification system and Aashto classification system. So I hope you learned for me. Thank you for watching and